Hey, what's up? It's your old pal, Mr. Cook, and we're going to work on 3.4, the odds. So with 3.4, we're doing solving rational equations. And there's a couple different ways that you can do solving rational equations. I'm going to do it the same way each and every time for my odd problems. And that's the following. So the first step that I always do is find the common denominator, or a common denominator. And then the second step that I do is I multiply the common denominator into all the numerators. And then the third step I do is solve. And then the fourth step I do is check for extraneous solutions. And I do that by just finding the domain of the initial equation. So let's go ahead and do these one by one. So circle all the denominators there, m, and m squared. So if I have m here, then I can multiply both of these by m to get to m squared. So that means my common denominator, or a common denominator, is going to be m squared. All you need is a common denominator. I'll show you how to get a really easy common denominator when we get into a couple of these later problems. But what you can do here is just, see which ones, you need to multiply to get to the biggest one. So like, for m and m squared, you're going to need to multiply everything to get to m squared. With k squared, and k, it's going to be k squared, and then with this multiplier of 2. And, we'll just go through that same type of pattern for the first couple of problems. Anyways, so the common denominator is m squared, so we multiply that in the numerator for all of these, every one of the numerators. So I get 2m squared over m is equal to m squared over m plus m squared over m squared. So what I've done is just multiplied m squared in the top here, and the top here, and then the top here. So and I can do that because of this equal sign. I can't do that when I'm just evaluating rational equations or simplifying them. This is what I can do if it's equal though, so it's a real easy way to kind of work through the problem. Anyways, so we have m squared and m in the top, and m cancels out from the top and the bottom. We're just left with 2m. And then m squared over m again, and m cancels out in the top and the bottom. We just have m. And then m squared over m squared, a number over itself is always just 1. Okay, so now this becomes a much easier problem once we simplify the expression. So if we subtract m from both sides, we get m is equal to 1, and that's our solution. Now let's check and see for any extraneous solutions. So what we can do is either plug it back in and see if we get any math errors, or just check the domain at the very beginning and see if it matches up with any of the solutions that we get. So the domain at the beginning, let's see, since we have m in the denominator a bunch of times, m just cannot be equal to 0. That's the only case. So this would be the only time when we'd have an extraneous solution, but since we don't, it checks out. So this is going to be a good answer. No extraneous solutions here. So no extraneous solutions. All right, 3. Find the common denominator. So I can turn this k into a k squared. I can turn this k into a k squared. So k squared is going to be part of our common denominator. And then you multiply any of the coefficients together. So 2, 1, and 1 just multiplies together to be 2. So 2k squared is going to be our common denominator that we can use here. So I'm going to multiply that in the numerator for each of these. So this times 2k squared, this one times 2k squared, and this one times 2k squared. So what do we get? 1 times 2k squared is 2k squared over 2k minus, and then that's going to be 2k squared over k squared equals 2 times 2k squared over k. All right, so 2k, so the 2's cancel out, and then one of the k's cancel out here, so that gets rid of the square, so we just have k minus, and then k squared and k squared cancel out, so just k minus 2 is equal to, and then one of the k's cancel out in the top and the bottom, so we have 4k overall there. All right, now I'm going to subtract k from both sides. I get negative 2 is equal to 3k, and then I divide both sides by 3 to get k by itself, so k is equal to negative 2/3. So that's my answer for k. I'm going to check for extraneous solutions. I can either plug it in and see if there's any math laws broken, or I can just check the domain. So 2k, k squared, and k, as long as they aren't 0, there aren't any problems there. So as long as k can't be equal to 0, we're good. So since those numbers aren't the same, then that means that there are no extraneous solutions. All right, easy enough for the first two. Let's go to the third one. All right, so we have an a squared, and an a. So I can turn this a into an a squared, and I can turn this a into an a squared. So a squared is part of the common denominator. Now let's check out the coefficients. So I can turn this 2 into a 4, and I can turn the 1 that's out front here into a 4 by just multiplying this one by 4, this one by 2. So 4a squared is the least common denominator here. So we multiply that into the numerators for all these. So 4a squared, 4a squared, 4a squared. So 4a squared times 1 for each of these is just going to be 4a squared. So we get 4a squared over a equals 4a squared over 2a squared minus 4a squared over 4a. All right, so let's see. An a cancels out here, so we just have 4a equals. And then the a squareds cancel out, and then 4 over 2 is just 2 minus, and then the 4's cancel out, and then an a cancels out, so we just have a. And then you solve it. So add a to both sides. 5a is equal to 2. Divide by 5. A is equal to 2/5. So there's your answer. Now let's check for extraneous solutions. So a, 2a squared, and 4a. As long as a isn't 0, then everything works out okay. So that's your domain. And then since the number's not the same, that means that there's no extraneous solutions here. And we're good to go. All right, now let's move on to number 7, and then that'll be it for this side of the worksheet, and I'll probably start a new video after that. So our denominators are r minus 7, the entire factor, and then this one is just 1 over 1. So I can make 1 look like r minus 7 by multiplying by r minus 7. So that means that our common denominator is just simply r minus 7. So we multiply everything by r minus 7. So 1 gets multiplied by r minus 7, so r minus 7 over 1 minus, and then 1 times r minus 7 is r minus 7 over r minus 7 equals 2 times r minus 7 over r minus 7. All right, so if we've done this correctly, we can just cancel a bunch of stuff out. R minus 7 over 1 is just r minus 7. R minus 7 and r minus 7 cancel out, so we just have a 1. And then the r minus 7's cancel out here also, so we just have 2. So let's combine like terms. R minus 7 minus 1 is minus 8 equals 2. And then if you add 8 to both sides, then you get r is equal to 10. So there's our solution. Let's check for extraneous solutions. So let's check the domain. The only way that any of those domains can be bad is if this ends up being 0. So if r minus 7 is equal to 0, that's bad news. So if we add 7 on both sides, r just can't be equal to 7. And we found out that, r is equal to 10, so there's, again, no extraneous solutions here. All right, so that's it for the first page. I'm going to move on to the odds on the back page. Looks like there are a couple more complex, or not complex. I shouldn't use that word anymore because we know what complex numbers are. Some more difficult denominators here. So, we'll work on that one next on the next video.